So today I'm going to discuss about rotation matrices. I assume that you all already know about vectors, right? So a vector V could be this. An example of a vector. How do we see it in space? A 3D vector in space will be something like this, right? And in terms of mathematics, a vector is also expressed in a different way, like a a column vector, right? So this same matrix, same vector can be represented like this. So there's just a different representation of the same vector. Many of you already know what a matrix is and how matrix multiplications operate, right? So when there are two matrices, how do we multiply them? When there is a matrix and a vector, how do we multiply them? So if I have a 3 cross 3 matrix, I know that I can multiply it with this 3 cross 1 vector, and I also know that the result of this multiplication will be a 3 cross 1 vector. So say I have a matrix called 1 0 3 2 1 0 0 1 7. This is a 3 cross 3 matrix, and it operates on a vector and spits out another vector. In this case, the vector that will obtain will be 2 minus 12, that is minus 10. 4 plus 3 is 5, and 3 minus 28 is minus 25. So this is the vector we obtain after multiplication with this matrix. The interesting thing is this matrix can be seen as a transformation of this vector into another vector, right? So this matrix is transformation simply the transformation of one vector into another. So there are special transformations, special linear transformations that are called rotation matrices. So there is a special kind of transformation called a rotation matrix, and what it does to a vector or all the vector is that it simply rotates them. So for example, if I look in 2D, a rotation matrix, which is a rotation about the z-axis, will, for example, rotate all the vectors v by an angle of 30 degrees, right? So such a matrix will be called a rotation matrix, whose action on all the vectors is to spit out a rotated vector.